Assalamu alaikum everyone. I'm Ajayul Hakim Chaudhuri Suman. I'm here to present our 461 project simulation, which is a line follower. For this line follower, we have used first of all 16 logic states as 16 light sensors. As this light sensor needs a lot of current supply, we have used 2 buffer IC for each 8 of them, and each buffer IC has its own power supply at pin number 11, which is here. And for voltage control, we use respect, and we have to use 2 respect for each buffer IC, and each respect has its own power supply at pin number 1. Now for processing and keeping in mind the price of microcontroller, we have chosen the Avier series microcontroller, which is 8 mega 16, and we have used terminals for the tidy arrangement. We have used port A and C as an input from the light sensors. Here you can see port A for buffer IC1 and port C for buffer IC2. And we use 16:2 LCD monitor for displaying the information transmitted from the sensors to the microcontroller. And for this you can see we have connected D4, 5, 6 and 7 to here to the microcontroller, which is pin number 4, 5, 6 and 4, 5, 6, which is actually 5, 6, 7 and 8. Yeah, and each LCD, this LCD has its own power supply at pin number 2, and we have used resistor for precaution actually. Now then we have used 3 buttons for the motors for increasing or decreasing the motor speed, and one enter button for going to the next step or next processing step. And then we have used actually a motor driver, which is L289 that provide high current for these 2 motors, and we have connected these motors to this driver circuit. For turning those motor left and right, we have used pin number 5, 7, 10 and 12, and which is connected to the 8 mega via the terminals, which is here 16, 17, 18 and 21. And for PWM, we have used pin number 11 in the motor driver and pin number 19 in the 8 mega. So for now we have to upload the hex file or firmware for the 8 mega. Let's do it. Here is the hex file, and we have used 8 megahertz Intel NAND crystal, which is already selected here. Let's play it. You can see the PWM is now 0. We can increase or decrease it by up button and down button. You can see it is decreasing right now, and for going to the next step we have to click the enter button. Here it is showing the LED sensors, which are all low. We can check if it is working right. You can see this is high right now, which is 1, and for 0 it will show low. You can check all of this. You can see that it is changing. Okay, now for going to the next step we have to click enter. So to move the robot left, we have to start the left motor and stop or turn off the right motor. For this we have to choose any odd number or odd sensors, which is here. Now it's moving left and this right motor is stopped. For moving right, we have to choose any event sensors. Now it's moving right as the left is stopped. For going forward, we have to basically choose all the sensors high. As you can see, it's all the sensors are high and it's now moving forward. Thank you everyone for listening to us. Now let's see the detailed 3D animation of our project. As you can see, this is the top view of our project. This is the left side view. This is the front view. And this is our right angle view. This is top view of our project. This is from the back side. And this is from the bottom side. Now let's talk about the motivation or where we can use our project. There will be the area that will be benefited from this project will be basically the industrial automated equipment carriers, entertainment and small household applications, tour guides in museum, and other similar applications. Thank you.